Hi friends, welcome back to Software X. My name is Lungelo Kwenene, and if you are watching us on Facebook, please follow us, and if you are watching us on YouTube, please do subscribe to our YouTube channel. TikTok gang, please press that plus sign next to our profile to add us. So today we are doing analytical geometry. So, analytical geometry, sometimes known as coordinate geometry, but the first part of this, we are going to be talking about just analytical geometry, mostly what you get in grade 10 and grade 11, and then the part 2 of this will be doing equation of a circle, of which is the addition in grade 12's work when you are doing CAPS. So now, analytical geometry. So we're going to start off talking about lines, right? Because this is basically the geometry of lines. So you have parallel lines, right? So A, B, C, D. So with parallel lines, we say if AB is parallel to CD, then the gradient, M for gradient of AB equals to gradient of CD. So you might ask yourself, how is this going to help you? So let's say, for instance, you are given something like this. Okay, X, Y. So you have a point there, right, and a point there. Say that point is A, and there it's B. Okay, so and then you have another line here. Okay, so you have a point there and a point there. So let's say maybe it's CD there. This is line AB, line CD. Let's just name it like that. So if you are told that this line is parallel to this line, and you are given the coordinates of A being maybe -3 and 0, coordinates of B being 2 and being 0 and 2, and then they say maybe here you are given D, point D here as 2 and 0. Then the question is, find the equation of line CD, this line. Find the equation of CD in a form of y equals to mx plus c. So firstly, you need the gradient. This m is for gradient. You need the gradient and you need the y-intercept, because c is y-intercept. So y-intercept is c, but you are not given the coordinates of c, and then you are only given one coordinate, and you know that m is gradient, so the gradient is actually the gradient of 2 points, the gradient of a line between 2 points. So that means you need 2 points. But if you are given that AB is parallel to CD, then you can calculate the gradient of AB. After getting the gradient of AB, because then the two lines are parallel, so line CD, the gradient of CD will be equals to the gradient of AB. So this is how you are going to calculate that. Y at B minus Y at A over X at B minus X at A. So it's your gradient, right? Gradient of what? AB. So then you substitute. Y at B is 2 minus Y at A is 0 over 2, Y at B is 0, X at B is 0 minus X at A minus 3. Okay, so therefore the gradient here, therefore the gradient of AB will be equals to 2 over 3. So then, but the gradient of AB equals to gradient of CD. Then you can state your reason. AB parallel to CD. Okay, so that means the line CD, the gradient of CD is 2 over 3. So y equals to 2 over 3x plus c. So now you need to find c. How are you going to do that? X and y are any points on the graph. So you have this point D, you substitute the coordinates there. So y would be 0 equals to 2 over 3 and 2 plus c. Okay, so 2 over 3 times 2 is equals to 4 over 3. So then you take the 4 over 3, oh, this is 4 over 3, you transpose it this side, it becomes negative 4 over 3 equals to c. Therefore, the equation of this line is y equals to 2 over 3x minus 4 over 3. And that's how this rule, or rather this, helps you with your geometry. Now, we are going to talk about the perpendicular lines, A, B, C, D, being perpendicular. So if AB is perpendicular to CD, then the gradient of AB multiplied by the gradient of CD equals -1. So also, this is going to help you when you are given maybe something like this. Maybe you are given something like this. So A, B, C. So let's say maybe they say here we have -4 and -2. There we have 1 and 6. Here, let's say we have let me see. Let's say we have 3 and -4. Just say. So they say prove whether angle A, this angle A, this angle. Prove whether angle A is 90 degrees or not. So what you have to do, you calculate the gradient of AB and the gradient of AC. Then you multiply them. Calculate gradient of AB, write the answer. Calculate gradient of AC, write the answer. So gradient of AC multiplied by the gradient of AB. If the two gradients, when you multiply them, give you -1, then this angle is 90 degrees. But if they do not give you -1, then it's not 90 degrees. So I'm going to leave you with this one to do it on your own, and then you are going to comment if it gives you -1 or not. So let's do a quick recap. Parallel lines, their gradients are equal, and then perpendicular line, the products of their gradients give you -1. So let's say now the last case, and then we are going to close this video. Angle of inclination. So the angle of inclination, normally you get it like this, maybe here being theta. So this angle, how you get it? Tan theta equals to m. So now this is how you get gradient when you are only given the angle of inclination. But if you are given the gradient of this line, but you don't know theta, then you say tan theta equals to m. Therefore, theta will be equals to tan second function m. And then you punch this, you will have your theta. Remember, when you get your angle as negative from your calculator, you always say plus 180 when your angle is here. Okay, so thank you for tuning in. See you again next time. Sharp.